So in this example, I have a pipe, all right, let me write it here, or what seems to be a pipe. Okay. Couple of forces applied to it, 4 forces as a matter of fact. I have 50 newtons downward, I have 60 newtons to the right, and 20 and 40 newtons both apply to the same point, one towards the right, one downward. And I have the geometry where they are applied. Now, my point or my goal is to find the moment or determine the resultant moment of all these 4 forces acting on this pipe about 0.0. So let's put it this way. Find the resultant I don't know if it's even a T. Resultant moment of the 4 forces about 0.0. So I'm trying to find the moments about this point, 0.0. So I'll follow exactly what I just said. Right? It should work. So MR, right, resultant moment, is summation of all the moments. Let's put it just M1 plus M2 plus M3 plus M4. Right? One moment associated with, or each moment associated with each force. Now, let's call this, I'm going to start from this side. Let's call this F1, so we know what we're talking about. F2, I'm going to call this F3, and go all the way there as F4. Next step would be, well, F1 D1 plus F2 D2. I just write everything with plus, then we'll figure out the direction and positive and negative values. So let's start with the first one, F1 D1. What is the value? What is the sign? Can someone tell me? Right, we're finding the moment of F1, this vector here, about 0.0.
50 newtons and 2 meters.
50 newtons, exactly. So that's the magnitude of the force. I can do better, 50 newtons times 2. How about the sign? Go with the sign convention. We said clockwise would be negative, counterclockwise would be positive.
Oh, so negative.
So that would be negative, right? This is this way, and then it's going to be clockwise, so this is negative.
Yeah.
Exactly. So F2 is 60 Newton. What is the D value? I'm finding the moment about 0.0. What is the perpendicular distance between the line of action that this force has and 0.0? 0, exactly. Oh, people are saying 0 in the chat box. Thank you. So this is going to be 0. Right? There is no distance. It's passing through that point. So we don't really even care about the direction. Well, there is no direction. Now, the next one is F3. F3 is 20. What is the distance? What is the D value for this case? Sine 20. I don't even know where did you get 20, Bobby? So this is D, right? 30, yeah. So this is D. But, well, if you're looking at the triangle, sine 30, you're halfway there. There's one more thing that is missing, the distance. We're looking for D. That would be 3 sine 30, right? Exactly. So that would be 3 sine 30, right? Now, what is the sign for this? Is it clockwise or counterclockwise? If it's clockwise, would be negative. If it's counterclockwise, would be positive. Can someone tell me that whether this moment caused by force F3 is positive or negative, following the sign convention? If you don't remember the sign convention,
Would it be negative?
I couldn't hear you. Sorry. What was the comment?
Would it be negative?
Well, it would be. So let's go through this. This is 4 fingers along the force, the palm of my hand towards the point that I want to find a moment about. Make a fist. So it turns out to be counterclockwise. And since it's counterclockwise, it would be positive. So that would be plus here. Refreshing your mind, this is counterclockwise, positive, clockwise, negative. Last force is F3, right? Plus, well, let's not put the sign yet. We'll figure that out. So, sorry, F4. F4 is 40 times the value distance. What is the value D for F4? Now, the line of action of F4, find that, the distance between that and point O, the perpendicular distance. That's 3 cosine 30, exactly. So 4 plus 3 cosine 30. Now, what is the sign for that? Sign is negative, right? Downward, palm of my hand towards point O, make a fist, makes it clockwise. Clockwise, instead that's negative. So if you do this math, you'll get the value of resultant moment. That will give you minus 334 Nm. Right? Since it's negative, it means it's clockwise. So you can either write it this way, or you can write it 334 Nm clockwise. So there was something in this example I wanted you to pay attention to, that for F2, you notice, moment M2 became 0. So this is a general rule. If the line of action of a force passes through the point that we are trying to find the moment about, in this case, line of action of F2 passes through point O. So if the line of action of a force passes through the point that we're trying to find the moment about, D becomes 0, and as a result, the moment of the force about that point is 0. So just keep that in mind. You'll see that over and over when you're dealing with a series of forces, multiple forces.